Hi guys, we're back on to the Admiral TV and some more on our comparisons and where I'm at on the TV. I've been working slowly. We've got pretty much this area is been done, and up through here and up into here and through this whole area. So from here all the way around, plus of course the IF section was done earlier, is been recapped, and any autonomous resistors has been replaced. And of course everything underneath here now is pretty well hooked up. There's one more lead that I got to bring down through and hook up, but otherwise this is all been done. All I got left really basically is some capacitor or some resistors here and a couple caps to replace. And this resistor, I'm waiting for parts for it. I had to order some power resistors. I did not have the value for that. So that's where I'm at on the TV. It's coming along. Probably a couple, at least one or maybe two more videos on it before I'm ready to do the first initial power up of it and see if it's going to work all right. Now, getting on with that, we'll move into doing our comparison between a radio and TV. Now, one point I want to make out on this is, as I do this comparison, and what we're doing is we're going to compare the basic circuits that are that are similar between TV and radio. Both the radio and TVs use. Now, sync circuits, radios don't have synchronization circuits. So some of that, we'll get into after that point. But one thing I want to say is doing the comparison is going to be relatively quick, going through each section and each circuit as we go through, because I just want to make the comparison, and so you can see that there's not that much difference. I will speak of the differences, but I wanted you to see that there is quite a few similarities. But once that's all done, then I'm going to go back and we'll go in depth into each of the individual areas and circuits, so that you got a better understanding of the full theory of operation of how everything works. And most of this is going to be pretty much no math at all. The biggest amount of math that will ever be involved in this will be some simple Ohm's law calculations, as well as probably some RC time constant calculation, which basically just multiply two numbers together and you get an amount of time in seconds. And of course Ohm's law is just voltage and resistance and current. So if you have any questions that pertain to going deeper into theory, just wait. I will be getting back to that after I get done with doing the comparison to the TV to the radio. The whole reason for doing the comparison and keeping it relatively low on the theory end of it and stuff is for those who work on radios, or you maybe even starting out and you started out with radios and everything and curious about TVs or whatever. The whole idea of this comparison is to show you that a lot of these circuits do exactly the same thing in the TV as they do as the circuits in the radio do. So your front end parts, the mixer oscillator, the tuned RF amp is the same in the way they operate. Their theory of operation is identical to that of a radio. The IFs the theory of operation is identical to a radio. Again, this is a superheterodyne receiver. Same principles of superheterodyne as in a radio. So I want to make the comparison so that you can feel a little more comfortable. And then when I go back and go in depth theory talking on these circuits, it won't be something that you get lost on as easily. So we're going to talk about the tuner, and we're going to compare it to the front end of the radio and how radio is tuned. And we'll look at the differences, we'll look at the similarities, and I'll make points of how there are radios that out there that also has extreme similarities. And in the fact that this tuner here, for instance, is a clunker type, it's a turret type. You just rotate it, channel 2, channel 3, channel 4. Other than maybe you might have to do a little minor adjustment of the fine tuning after you click into a channel, depending on weather conditions, atmospheric conditions. Other than that, it's on frequency and it's there. So this is basically preset. But there are some radios that have presets, and we'll get to that in a little bit. I'm going to show you a couple different styles of these, and we'll talk about some other different ones that are of this design. Now, there are tuners out there. There are basically inductive tuners, or where they use a couple different means, but they basically are varying the inductance of coils to change channels. And there are also tuners in some TVs that were just literally like a radio. They had, or at least most radios, they had a variable condenser that you rotated. Now those, both the variable inductive or inductive tuners and the variable capacitive, were like a radio. It's kind of almost infinite. You can just keep turn it, and depending on your, there's infinite number of angles of that dial that you can set. I mean, there's basically some general areas you want to be for channel 3 and channel 2 and channel 5 and 4 and 6 and whatever, but it's variable. Whereas these they're basically like a rotary switch. They lock in to channel 2, channel 3, channel 4, and so on. You got the turret style of this nature, which I really like because it's extremely rugged. You also got another style, and then there's variations also. But there's another style where, and there's various different styles of turret styles, but turret styles are really usually fairly rugged. Then there's another style that some of the other were on lower price sets, and then later they started doing this in all TVs, which are basically they're just rotary phenolic wafer switches, just like you would have on a band switch in a AM shortwave radio. Multi-section band switch. There's just multi-section. Could have 2, 3, 4 rotary wafer switches in there, and those can give you troubles just like the band switches in radios. They get dirty. They're not the easiest things to clean. They are somewhat delicate. The switches themselves, the contacts, are extremely delicate, so you got to be careful with them. The other thing about them, especially the ones that were built on the chassis and underneath the chassis, they could be quite exposed, and that meant there were several coils that's on them for the different coils for the different stations and channels, and they are just out in the open. And if you were in there messing around, doing restore or something, and you're not real careful around that area, and you bump on them coils, you knock it out. You knock it out of whack. It changes its inductance, so now it's not going to work right on that channel, and you'll have to readjust it. And a lot of those, they didn't have no slugs or anything. They adjusted by expanding or compressing the coils to get them adjusted just right. Now I do have another basic turret type tuner that I brought up. It's out of a little bit newer Admiral than this, about 5 years newer, 6 years newer, something of that nature. And it's a somewhat different design. The unique thing about it does show them coils. It was in a box of stuff that I got once. So, and it was, let's see if I can get this in here. Okay. You have two sections here, two switches. These switches here make contact right down in here. It's very similar to this tuner here, as far as these contacts and the balls that make contact here. The same way, these contacts here will make contact right down in here as you rotate it. So, and it's got the same ball. It's made by the same company. Just it's newer. It's a little different design. The biggest thing is I wanted to show you is that here's these coils. If they get bumped, it will really knock them out of whack. And like I said, some TVs to actually make your adjustment, there was no slugs. And what they tell you to do is to either expand these out a little bit or squeeze them in a little bit to get what frequency, get your frequency adjustment correct. This one, on the other hand, actually does have adjustments here and here, here, and there's a couple more down in there. This tuner actually adjusted by one of these would adjust like a certain set number of channels, like 2, 3, and 4, and so forth and so on. So, but this is a little bit different design. It's fairly rugged. There's a cover that's supposed to be over this. The cover didn't come with it. It was just in a box with stuff. But there'd be a cover actually over this, and to close it up so that everything was well protected. The fine tuning's a little different in this one. This one here, we're moving a plate, which is right here. There's another plate where the wire, if you can see that wire going in, there's a plate on this phenolic insulator. And when you rotate this, you're basically rotating that plate in and out from that. It's kind of like a variable, like your tuning condenser. This is the least amount of capacitance. Always the other extreme is the maximum amount, and of course anything in between. Whereas the one that's in here is got a phenolic that's hooked to the shaft. This is actually what you're doing is as you move this, you're changing the amount of that phenolic that's between the two capacitor plates. That's the dielectric, so you're adjusting the dielectric in this case. The higher the capacitance will be when there's more of this in there, the more you put in. As you turn it this way till it gets to the stop, that gives the maximum amount of capacitance. And when it's turned the other way, all the way out, this is like a cam wheel, so I mean it gets smaller and smaller in diameter as it goes. When it's turned all the way the other direction, it's virtually out of between the two plates, and you have the least amount of capacitance. But otherwise it works the same. That's your fine tunings. So now let's make our comparisons here. And if you ever wondered what's underneath one of these, I got a whole bunch of them, but I thought I'd bring one out and show it to you. This is the one side. This is actually the oscillator mixer coil set. It'd be this set right here. So this is what you normally see, and you can pop them out, and you got 3 sets of coils. You got this set, and this set. And one set here, this set here, hold this up. This set here goes to actually the plate of the RF tube. This set here goes to the grid of the mixer, and then this is the oscillator coil. And this one is adjustable. It's got a slug in it, which is right in here. This thing is only about a quarter inch, a little bit longer, and a quarter inch, maybe 3/8. It's not real long. It's fairly short. It's about they're about this long, right here. You see my thumb? So this little spring right here is what actually holds it in place and allows it to thread. If you adjust it, you shouldn't have to adjust it much if you ever need to adjust one. It should be just very minor turn one direction or other to get things in. But if you was to crank it all the way through, once it gets past this point of this, it'll just drop down inside here. Now what then you have to do is you got to you want to take and lift the spring and move it to one side so it's not down in there's a groove right in there that is in the tube, and you want the coil form, and you move that up to the side, and then you just keep trying to tap it down. Well, hopefully it will fall down. You might take a very thin piece of wire and kind of help shove it and get it back out here where you can put that spring back in place, and then it's back in place. But it can be kind of fun and a little time consuming, so if you ever get one of these, don't crank it too much. If you got to crank it more than a turn one way or another, most likely there's a problem somewhere else. So it shouldn't take much to turn it. But that's what they look like. The other side just has one coil on it, well actually two coils, the antenna coil and then the secondary. And that's all it's in those. So now let's compare this to radio, and we'll take a look at the radio schematic we've been looking at. And I'll kind of zoom in here. These wires all the way. I just got that set in there just to kind of keep that thing from going down on me. A little bit there. Hopefully you can see this. Alright. We just have two tubes. We got tuned RF tube here, and then we got our mixer oscillator tube here. And our antenna system feeds in. We've got a set of different coils here because this is a multi-band radio, so there's several shortwave bands. But basically what happens is your signal comes in, feeds in, and makes its way through the switch to L2 here. This is actually the antenna coil for the broadcast band, and it's connected to the tuning condenser. This will feed a signal into the RF grid. That tuned signal goes in the RF grid. It's amplified. That feeds through this coil here, which going down through the switches goes through its tuning condenser right here, its section. That is coupled, here magnetically coupled, to the secondary, go down through the switches, and it comes back up and goes to the grid, to the mixer oscillator. At the same time, there is, down in here is your oscillator coils. Whichever one switched in will feed back up into the plate circuit here. And feed into this, oscillate, get it oscillating. The way this tube's actually designed, it's got a common cathode, and that's its actual connection to feed the mixer tube. The two mix. The difference between them will then be fed to the IF. Now, as I said before on these, what actually comes out of here is 4 fundamental frequencies and a whole bunch of harmonics. You have what you tuned in, the radio station, its frequency coming out and not been changed or bothered, unmolested. You got the local oscillator frequency coming out of the plate, unmolested. You got the two added together coming out, and then you got the difference between the two. And the IF is adjusted and aligned to the difference frequency. So that's the only frequency it's going to let through. Now that's basically the nutshell of how this works. It's no different than any other radio, other than a lot of radios don't have an RF tube. They just goes directly into the mixer oscillator. This radio does have an RF. Now if we go up to the TV and compare it right here, and move over a little bit. Alright, we have the antenna here, and we feed in to the antenna coil that's magnetically coupled to this coil, which is a secondary. That secondary then feeds into the grid of the RF amp. That grid of the RF amp, the grid controls the RF amp and the current going through. So we amplify, we come out, we come down, we go through the tuned coil for this RF amp. That is coupled with these three coils. They're on the same, that's these coils right here. That's it. L2 here is these guys right here. Kind of hard to see. If I can get it to focus. Anyway, that's these three coils. Alright. You got the RF, and then you got the next coil, and then the next coil. They all are magnetic coupled together. So this signal is coming out of here is magnetic coupled to here as well as to here. But this one here is also putting out a signal. So these two go into this coil, which feed into the mixer. And once in the mixer, they get mixed, amplified, and then sent out to off to the side here to the IF. Now on this schematic it says 2.31 megacycles. They put the dot in the wrong place. It's 23.1, so that's actually wrong. Anyway, now again, what comes out of the mixer is just like the radio. You have four fundamental frequencies and a bunch of harmonics. The first fundamental frequency is actually the station you're tuned in, channel 2, channel 3, whatever. Its frequency. Unmolested, not bothered. The second frequency is the local oscillator frequency. The third one is the two mixed. And the fourth one is the difference between the two. The difference between the two is the IF frequency for this TV. But the actual theory of operation is the same. Just like the radio, we got the tuned RF. It's tuned by this coil here. We have the antenna coil assembly here. We have the oscillator coil here. These two coils right here are literally exactly the same as these two right here. That is the same thing right here as those down there on the radio. So they operate the same. What is the differences here? Now in theory the operation is the same and it works just like a radio. Again, you got the RF, you're amplifying it, but the main portion is this right here. You got a local oscillator and you got a mixer tube. You're mixing your antenna frequency, the station frequency, with the local oscillator frequency, and you're looking for the difference. The difference is what will go through the IF. Nothing changes. It's the same. The big difference is here is number one, frequency. There's a lot higher frequency than this radio is. You know, the radio is 550 to 1650 kilohertz. This is running in the neighborhood of 54 megahertz up through 200 and some megahertz for channel 13. So much higher frequency than this radio, more than 50 times the frequency range, about 100 times the frequency range. So frequency is different, and that's going to dictate in how the circuit's designed. Higher frequency, you have different inductances, you have different capacitances, and so on. The other thing that's different is this is wider bandwidth as opposed to the radio. So this is considerably wider bandwidth than the radio. So that's a big difference. The third difference is in this particular style TV, and in the majority of TVs, not all. Again, there were TVs that had variable tuning. Had either variable inductive type tuning or variable capacitive type tuning. But most TVs were basically pre-select. In other words, it was a switch. You had, you know, if it's just VHF, which is 2 through 12, you had those 2 through 12 switch positions. What they did was they switched in different coils, and that's what this one does. Each of these are different coils for different for different stations. So channel 2 has its own antenna coil and its own mixer oscillators coil set. Channel 3, same way. Channel 4, channel 5, and so on. So this is more, you know, it's preset. There's not really, the only variance, the only even slight little bit of variance is fine tuning. Otherwise, you just flip the channel clunker to the channel you want and you walk away. Now, whereas in a radio, you got variable tuning. You rotate the tuning condenser, or some radios did have an inductive type tuning where it adjusted slugs into coils. There is a similarity, though, to this and radio. And actually, one particular TV I think off the top of my head, the model number I can't remember, but a Helicopters TV was similar to this. In some radios, you have automatic push button tuning, preset tuning. You got your regular tuning dial knob, and of course volume control, and then maybe a band selector, and depending on what's all on there. But you've got a set of push buttons that can be adjusted to certain pre-selected frequencies for certain radio stations. So that if you don't want to mess around rotating the dial through to different stations, you can hit one button or the next button or the next button. You can have 6, 7, 8, 9 different presets, and you just push a button and it takes you right there to that station. Now, there were two different ways of doing that. One was mechanical, some mechanical means, including even little electric motors and gears. But basically, the mechanical means, all it did was some sort of mechanism that was used that when you push that button, it literally turned the tuning condenser. The other method is electronic. Electronic automatic tuning or preset tuning, you got a set of coils and a set of condensers, and both are variable, and generally most of them what you adjusted was more to get the preset was just the patter condenser, trimmer condenser, but you would adjust those, and once they're adjusted you got that preset, and then nothing else was touched anymore. Those presets are very similar to this turret tuning, basically, because when you hit each button, you're bringing in a different set of coils and a different set of capacitors. In this case, basically all we're doing is changing coils, but it's really very similar in the way it works. So they're all preset, just like these are all preset and pre-selected and designed. Now, one TV, the Hellcrafters actually had push-button tuning on some of the, at least on one model, and I think there was a couple, 3 different models that had that. And it was actually very similar in design to the radio electronic preset. Did have a set of coils, but you actually made the adjustments by pattern condensers on there that you adjusted, trimmer caps. And once they were adjusted and properly set, you didn't have to bother with them anymore, so you hit whichever button, channel 2, channel 3, whichever one went with channel. So there are definite similarities to this preset type switching non-variable to a radio. There's also very much similarities in actual theory of operation, tuned RF. It's the same thing as in the radio. This is no different than this. It works the same way. We feed a signal in the grid, it gets amplified. We have tuning on it. We tune the plate. That's what makes it tuned. We're tuning the plate here. We tune the plate on this. Right here. This coil. We do have some trimmers. These are for alignment purposes. But there's a trimmer for this coil right here. So, once it's set, it shouldn't have to be bothered anymore, but it's there. When we get into, this is feeding this coil, which feeds into the mixer. Low transformer. Literally the same thing is right here. This primary feeds this secondary, which feeds into this grid. Now, yes, it's going through these switches and stuff. That's only because we got multiple bands. But if we only had a single band, it would go directly there. So this all works the same. The antenna circuit works the same. It is adjusted. In this case with the radio, we're moving a variable capacitor. In the TV, we're actually just turning the channel selector, which puts in different coils that match up to that frequency. But it works in the same theory. The mixer and the local oscillator works the same. In fact, this one and the one on the TV is literally almost identical, other than the mixer part. The radio has a triode oscillator. These are one tube, same way as the radio. Now, there are radios made that you have a separate oscillator tube, and so you'd actually, the front end, if you had an tuned RF, would mount to 3 tubes. Tuned RF, mixer, and oscillator tube. TVs also have 3, there's some TVs that were built with 3 tubes in the tuner. In that case, you would have a separate oscillator tube, separate mixer tube, and a separate, of course, RF tube. But in this case, we're only 2 tubes, so these 2 are combined. But the signal still feeds in here. This signal still feeds in here. They're mixed together. The difference of those goes out to the IF, and the IF only allows the difference to come through. So they're operating, the theory of operation is identical. There's no difference. The only differences you're dealing with here is the frequency, the bandwidth is the only 2 really main differences that's in here. So due to the frequency, the coils have less windings. The capacitance is a lot less. So, as opposed to the radio. That just comes from the basic resonant formula. So, because they're inversely proportional to each other. If you want frequency to go up, you've got to reduce the inductance and capacitance. If you want frequency to go down, you increase the size of the inductor and capacitor. So since this is about 100 times higher frequency range, then basically what you're doing is you'll have a lot less coils. And you can see this in the higher end of the channels with this set of coils here. There's not very many windings on there, and I think this is about like channel 13. The markings are pretty much completely off of it. I don't even know if I can read it myself. Oh, no, that's channel 7. Okay. But there are a lot less turns in that than you would find if you look in the radio, and most of you have seen the coils that's in there. So the biggest thing that is the frequency difference and the bandwidth. Once you get past those two things, the circuitry works identical to the radio. So if you get to understand the radio circuitry, that same theory is working here. So now when I come back to this, after we're done with this more of a simple comparison, then we'll go into where all the capacitances is, because you're used to seeing a tank circuit, a coil with a capacitor across it in parallel. That seems to be non-existent here. We'll go through that. We'll also go through why these coils exist right through here. This last one's down here. We'll go through why this capacitor's here and this capacitor's here and so forth. And we'll talk about all the individual components and how, you know, the in-depth theory of operation. But actually the theory of operation is very literally identical. You know, you're basically picking up a signal, you're tuning it, you're amplifying it through an RF amplifier that's also tuned. You feed that into a mixer tube. The mixer tube has an oscillator that's also there because it's superheterodyne. That oscillator also feeds in the mixer. The mixer literally mixes the two frequencies. The difference of those two frequencies will be what is allowed through the IF, and then of course from there the IF amplifies it and sends it on down the line. So that's about all I've got on this. When we on the next video we'll move into the IF section and talk about it and stuff. And again, like I say, once I get through the circuits that are real similar, including the power supply, then we'll move into talking about these more in depth, and also looking at in depth the circuits that radios don't have and in them, that only TVs have. So this is going to be a long series. I apologize for that to a certain extent, but just bear with me. We'll get through all this, and I hope that the end result is that you find TVs not so mysterious if you've never worked on one. And I encourage you to get one and to work on one. We will be doing a video talking about safety. So until I get to that video, be very cautious if you already bought a TV. And in fact, that may be the next video, because maybe I should hit that before I continue on with this. So with that, I think I'm going to end the video here and let you guys let your brains rest a little bit, and you can kind of digest this and stuff. But these circuits may seem complicated at first, but when you break them down, they're really not that complex. So, and as we go in depth into them, I'm hoping that you'll see that they're really not that mysterious. So, again, this is going to be mostly, everything on this will be mostly theory, with very little math. And what little math there will be real simple math. Again, like Ohm's law, we'll do probably some calculations, Ohm's law, and a little bit about RC time constants, but that's about it. I can't imagine too much anything else at this point anyway, at least not math oriented per se. I mean, I might throw numbers at you like frequencies, like 23.1 megacycles or 25 point something megacycles or whatever, but those are just numbers dealing with frequencies. So anyway, with that said, I'm going to go ahead and end the video here. If you have any questions, leave them in the comments. If they're real simple for me to answer, I'll answer them in the comments Otherwise, I'll make a follow-up video as I usually do. And I want to thank you ahead of time for watching and for subscribing, as well as for your comments. I still got to get back to some of the comments on the one before this, and I will get to this, but in advance, I do thank you for all your kind words and your encouragement. And you know, if you like the video, give it a big thumbs up. If you're not, if you're new to my channel, you haven't subscribed, please subscribe. And there's more to come. So thanks for watching, guys, and have a good day.